Gut, dann pünktlich wieder wie die deutsche Eisenbahn geht's los.
I think we should talk
yeah.
in English.
Sorry.
Yeah?
All right. Yeah, I recently taught in German, so sorry for that. Okay. Yeah. On time as the German train, we will start today in the week 3 of OOP1.
That sounds better in German.
Yeah, sounds better in German. This week we prepared something that you will need for also the assignment. We also read on Studo that there's very mixed feelings about assignment 1, but I'm pretty sure if you are always in the lecture and if you learned also what we did so far in the Vorlesung and also in the Konstruktionsübung, then you will have a good time with assignment 1. What will we do today? We will talk about classes again and scope. This will be actually the hot topic for today. By classes, we will just actually continue working on some things that we still missed last week to provide you with a deeper understanding of some concepts and also some other C++ features. And by scope, we will mainly talk about the lifetime of objects. So how long will an object live? What will happen after an object isn't available anymore? What will happen with the memory? Things like that.
Yeah, in addition, we have a few things left which are new in C++, like const or static. Yeah, and this is also interesting for the assignments, so I will talk a few minutes about that.
That sounds great.
Also today, I think we will do a short live programming together. Will be interesting.
Will be interesting. Okay, you will make a Slido first. Okay.
Yeah, so we also again have our Slidos. So I think there are 4 or 5 questions for you. Of course, you will see also this code afterwards, but if you want to join in advance, please feel free to do so. I think we will come in a few slides to the first quiz then. And another short announcement is that our research group organizes a hackathon. So if you want to participate, I think I already wrote it into the Discord server. If you want to participate, you have the option of free beer and pizza in the evening. So if you're not attracted by the hackathon, maybe this will be interesting for you.
And anyhow, the research project is pretty cool. It's the Open Web Search project. So the idea is to build an alternative search index to Google, actually. There are a couple of European organizations involved. Also, the European Commission is very pressing on that topic. So it's very important also for the Commission to have something independent from existing search indexes, actually. And technology behind that is also pretty cool. And in this hackathon, the idea is that you can also participate a bit in that, write some front ends. Also, you can write some plugins for the existing search engine. So this is really pretty cool, besides beer and pizza, yeah.
Of course, yeah.
Yes. Good question, actually, David.
I think you will have the opportunity to sleep. So you don't have to be there for 24 hours, but I think that's the time frame where
most of the magic will happen.
Yeah, where there are people around. So I don't think you have to be the whole night there. Great. So let's do a short recap.
Yeah.
And I think this is without a quiz, but this is the BET class we had, I think the whole last lecture. And there are a few components we just want to recap and, keep in our memories, like the class member variables, in this case a string and an integer of this pet. Then we have this access specifier, which are private or public. Private means they are not accessible from outside. Public means they are accessible from outside. And I think we will also show you more about this today. And then we talked about constructors. We had this constructor without arguments, also often say it as default constructor. And also if you read this CTOR here, this means just constructor in literature or also in Stack Overflow or whatever. Programmers tend to be very, I'm looking for a nice word for that. Faul in German.
Lazy.
Lazy. So they often write CTOR for that. And this is another constructor with arguments and an initialization list. We will also use this initialization list today. We also talked a little bit about Destructor, but I think you will show us a little bit more today.
Yeah, right. Today we will talk a lot about the Destructor as a way to get rid of an object, actually. So this is called when the scope, the lifetime of an object will end. And today we will see how to apply this, especially when we get some memory on the heap.
And we also talked about getter and setter. So to access all these private members, we want to have getter object or getter methods to get the objects here or the members here, and setters to set values of these private members. All right. Before we go to all this constructor and classes stuff, I think we should go to const, so constants in general. And think of like a friend of you says C++ is such a straightforward and easy to grasp language, and you show him this. This is a valid method inside a class, like our pet, for example, and it would make me headache if I'm new to that, but we will go through this and we will have a look in all this const here, what is the meaning of it, and hopefully after this, let's say 5 or 10 minutes, you have a better understanding what all these consts stand for. So I think, in general, const means like making a promise to the compiler, I will not change this variable. Think of like a constant, is we have it in C, we had this defines, or also we have constant there. You just say to compiler, I don't want to change it. And if you change it, the compiler says it's not allowed. You are not allowed to change this variable. But in the slides, it's a little bit hard to show it. So I switch to VS Code. Is this big enough, or should I make it bigger? Big enough?
Perfect.
It's interesting. He says bigger, and you in the back says it's fine. Okay, I'll try it. Oh, that's very big. Let's see. All right, so let's say we have here our const int age. I don't know, give them some value, and then I want to say age is 2. Obviously, here there is a problem. Expression must be modifiable. So it is not modifiable here. That's a very obvious problem. I can't do it. So this is the meaning of const in general. Let's try it a little bit different. Let's say we create a pointer, and so this is the right one, and I take the address of age. What am I missing here? Okay. It says, a value of type const int pointer cannot be used to initialize an entity of int pointer. So again, it says this does not work. I have to make this const. Does this work? Yes, it will work. So as you can see, const is, like I said before, a variable which you cannot modify. But the problem is there are different kind of const. So let's suppose another example here. Let's create another example. We have here an ID. This is just a random variable. And then we say I have a const integer, again my pointer, pointing to my age. And now I want to modify the value here inside. And I say the pointer is 2. So I dereference my pointer, and again I have the problem here. This will not work because I'm modifying the actual value here inside. But what I can do is, for example, I can modify my pointer to the address of ID. This will work because when I write this const here, it just says I'm not allowed to modify this actual value, but I'm allowed to change the pointer here. When I want to have both, I have to write again here another const. So this is then where the magic happens. This const here means that I am not allowed to change the pointer, and this const here means that I am not allowed to change the value of the pointer. So dereferencing and changing the value of the pointer. That's, I think it's pretty hard to read, but you will see sometimes constellations like this, and you will also see constellations like this, and it's pretty much the same. So maybe we can remove this one. You can write this const here, or you can write this const here. Doesn't matter. It always means if here is a const, so before the asterisk, it means that you're not allowed to change the value, and it's after the asterisk here, you are not allowed to change the pointer, and if it's on both sides, then you're not allowed to change both. So the pointer and the value. Are there any questions to this? Yes.
Yeah, sure.
So the question is when I put this here below, but the problem here is then that my pointer is not declared already. So of course I could write here then int pointer. This will work because again this is not a constant here. But if I do not declare it, I can't use this variable because I declare it in the next line. Was this your question? Okay, are any other questions? All right, so when we go back to the slides, this is just what we have done now, again in the slides. So if you want to download it, you can have a look at it. But when we remember back to this cool thing here, we now know all of them because it is the first const, int, pointer, const. We have seen it, and this inside here, the parameter is just again a pointer, which is const on both sides, so you cannot modify the pointer and you cannot modify the value. But this const is still missing. We don't know what this const is about there. And we have seen it already when we remember, I think from last week, where we had this pet class and Alex talked about this age here, or this getter and setter methods. He wrote already here a const. And this const just means that this method is not going to modify the class. So this method is not allowed to do any modifications inside the class. And if I write a getter method, which should just give me a member variable, it should not modify. So getter should always be constant. So now we know also the last const. And when we want to describe this method is of a class that takes a pointer, which value and pointer is not modifiable. It's just a parameter here. It returns a pointer which value and pointer is not modifiable. This is the return value. And the method do not modify the class itself. This is this const here. I know it's hard to get. And of course, this is a very, very hard example. But I hope you have seen it's not that big issue. It's not that big deal. And for me, the most important thing is this const here says that it does not modify the class itself, and you should also write it when you create your getter methods. All right. Then I have my first quiz for you. So which const produces an error here? So I have this code. Of course, you can assume that all the libraries are included. I have this code and I want to execute this, so I want to create a pet, but I have problems. So which const is the problem? Number 1, number 2, or number 3? All right, let's have a look at the results. Number 3 is correct, yes. So when we go back, this here, as I said, this here means that this function or this method, this function inside the class is not allowed to change the value, in this case, the age. But of course, what I do is I set the value here. So I modify the pet, and that's a problem. And the compiler says you are not allowed to do that in this case. All the other things are in general allowed. So I can hand over a constant here. Of course, I cannot modify this value here because it is a constant. And I return a constant, which means when I use this value here, I can also not modify it. All right, then.
And you've learned from last week.
Yeah.
Yeah. We shouldn't put the results too long on the screen.
But the cool thing in this case is they are not allowed to add multiple things.
Yeah, sure,
yeah.
Sure.
So I learned, yeah. But they still can change their opinion. Okay, so a short conclusion about const. Compiler does not allow the modification, so you give kind of a promise to the compiler. Constants must be initialized at definition, so you cannot write const int and initialize the value later on. You have to initialize it at the definition. Getter methods should be const because they only should give you the attributes back. And objects, variables, parameters, or whatever should be const if you intend to not modify them, so they should not change. All right, then let's go to static, another short keyword which you should know, especially also for the assignments. And there are again two types of static. We have static attributes and static methods inside classes. And static attributes are Yeah, there's a special case of attributes because they only exist once for all the objects you create from one class. So let's suppose we have here a car class. We create hundreds of cars, and this static value here, so this member variable number of wheels, only exists once for all, because sometimes we want to have attributes that are the same for all variables. So for all objects in this or of this class car, they should have the same value, in this case the same number of wheels, and you can access them. So you first write just static int, then you should initialize them outside of the class with a value, and then you can access them with this double colon here. So you enter like the namespace of the car, of the class, go into this namespace of the class, and then you can access the member variable. So as I said, there is only one instance for all attributes of all objects of this class, and they are accessible via the namespace. Yes?
Could we also initialize it inside of the class?
No, does not work. You have to initialize it outside of the class.
Otherwise, it would look as it would be part of the class. So this is the idea behind that, actually. So as David said, we will have an example on it later. This is not for a particular object, it's for like the entire class, yeah. Yeah.
So you need to initialize it in a function, like in the main?
No, I think you have to initialize it outside of functions and outside of classes, so globally. Because it's not bound to a function, not bound to a class. It exists once for the class. It is like you have your class definition also globally for all the functions available. And you also want to have this value here available for all functions and all classes. That's why it makes sense to declare it globally. Yes, there in the back, what question?
Does the initialization have to be in the same file as the main function?
No, does not have to be in the same file. So it makes sense to do it next to the class, not always in the main function, but it makes sense to do it next to the class because they are somehow bound together or belong together, but you can initialize it wherever you want.
So is it possible to change the value of the in the main afterwards?
Yes. You can modify static attributes. You can also combine const and static. Then you have a static const variable. This is like a static variable, but you cannot modify it then. But normal static variables are modifiable, yes. I think here was also a question. Yes? You.
Actually, you can initialize it in main because you can like change it in main, so why not initialize it? Is it possible?
So it's possible to write like this here,
We can just move it into main. Yeah. Maybe not.
but then it's accessible from outside the main. Don't think so. Yeah, I've never tried this before. So in general, in my opinion, it does not make sense to do it in the main because in the main you write local variables and this is bound to the car class and not to the main. It is possible. Okay, thank you. Yeah. Another question.
When it's a constant static, do you then have to declare it in the class? Because you can set it outside.
When it's a constant static, you also declare it outside. You can declare it and you initialize it outside. It's also possible, yeah, but we will have an example later where we do it. To maybe it's make more sense then. Yes.
If I inherit from the car class, can I still use the number of wheels?
So yeah, we will come to inheritance later. I think it's after the Easter break, and then we can talk about inheritance. I think now it's when we didn't discuss inheritance, it will be too much for most of the people. All right, I think we should continue because we have enough or still things to do. So as I said before, and as we have seen now, static attributes, they share this variable here. So when I create two cars, and by the way, I can also access this like they are the member variables, and they are really pointing to the same variable here. So if I say, okay, I want to change the number of wheels from this car, it will also change the number of wheels of this car. So they share one variable here. Another thing what we can do is, and what is often used, are so-called static methods. And think of a normal method, but the only difference is that you have here a static keyword before. So they are the same for all objects. And as we have seen before, you can access these methods like this with this double column here. So you enter the namespace of the car and then access the method here. But it has one disadvantage. It is, as I said before, generally available for all cars, so for all objects of this class, so you cannot access members. So in this case, we have a member variable people here. You cannot access the member variable here because it is for all cars and not for one specific car. That's why these static methods are often used for things like, I don't know, a message or methods that are, or behavior that is the same for all cars or for all objects of a class. Yes?
Would this work with a static variable?
This one here, yes. If you have a static variable here, so if this people would be static, then it works. Then you can access this because it is again not bound to an object. Yes?
If I, for example, make a different variable, for example, car like Skoda, and then I make the Skoda display message, will it work?
No, this won't work because it does not know, it does not really belong to this class. You have to access this like car double column display message.
Yeah, I mean, like, if I, for example, make the part of the class Skoda, so like a member of the class Skoda, and I will then assign a number of people to Skoda.
Yeah.
Can I still like access to it through display message?
So you mean you create a car object and then say, I don't know, Skoda dot display message. Yes, I think this should work, yeah. Yeah. It should work, yeah. It is. Does it work? So in this case here, you can access it. And in my opinion, you should also be able to access the static variables, but I'm not quite sure. So normally you will do it using the
Scoping operator.
the scope operator and write just the class name, go into the class, because you anyhow cannot access the member variables here. So there's no difference if you call it like from an object or from the class itself. Yes.
Do I need the keyword static in front of the method or case of the height? The other function that said that was that it always prints high class. Do I need the static? Yeah, do I need the static in front of it?
So the question is, do I need the static here? No, you don't need to have the static here. But when you remove the static here, you have to first create a car object and then say Skoda.displayMessage. And then you call these methods from this specific object. In this case, this is just a general way to call methods inside an object or inside a class without creating an object. Yeah, so you can write Skoda dot. Okay. Yeah, but in my opinion, it doesn't really make sense because you anyhow cannot access the member variables. But great, thank you. All right, again, a short quiz about this static thing, and then I think I've used too much time for that.
That's okay.
But then it comes your part about constructors and the more interesting thing. So what is the output on this code snippet? So we create a car class. We have one static variable, the number of wheels. And then we create two cars, the Mercedes and a Ferrari. We give them different number of wheels, and then we want to print out the number of wheels from the Mercedes. All right, let's have a look. The correct question would be 4. Actually, it works because you can access this Mercedes and this Ferrari here, and you can override it. But as soon as I override here this number of wheels, it is overwritten for all objects. So in this case, it works that the Mercedes only have also again 4 wheels in this case. Yes? No, there is no warning. So you can do it like this, but yeah, it's not very common to do it. But sometimes it makes sense because sometimes you have like a pointer to a car maybe, and you do not know which object is it. Is it like you have a car pointer and you don't know exactly, is it the Mercedes now, is it the Ferrari now? So you can't just say, okay, car dot number of wheels. It's anyhow for the same for both cars. All right, now it has changed. Interesting. And a short conclusion about statics. So we've seen that static members or static attributes, they have the same variable, have the same value for all objects of this class, and you access them via this double column of the class. And we have static methods. Again, they are the same methods for all objects of this class. You can access them via this double column, and you cannot access attributes of this object because it cannot, there's no connection to the attributes, so it only can modify or access static attributes of this class. There was a question, I think. Yeah.
Maybe I didn't get it the last slide. Here it says you need these two, this class.
Yeah, this double column, yeah?
Double column. But why does it work with only one column on the
It works. So it is also accessible like when you have an instance of this class and you can write, I don't know if we had before Mercedes.method, for example, or here Mercedes.member, it will also work, but this is the common way to do it. In most of the cases, I can't think of any case where it makes sense to not use it like this.
So you could either use class with 2 columns or the object with 1 column.
Yeah.
It's basically the same.
It's the same. You call the same members in the same function. Yeah. All right. I think now it's your
my
turn.
turn.
It's
Super.
getting a little bit more interesting, but we have to do this static and const because it's important for the assignment.
Right, now switch back to object-oriented programming. Last week we talked, basically almost half of the time at least about what a constructor is. And we will continue actually with a specific type of a constructor, the so-called copy constructor. I will start with a formal definition, which maybe sounds a bit overwhelming, but then we will go into detail and then you will see that this is actually quite easy. So formally, a copy constructor is a constructor which can be called with an argument of the same class type and copies the content of the argument without mutating the argument. So actually, this is the idea of that we copy something. The copy constructor means we copy an object to another object, and this is actually what a copy constructor does. Here I have an example. So let's go through it line by line. I think these are things that we should recall anyhow. So here we have our member variables. I think this is quite obvious. And here we will have our first constructor, which is initializing the object or creating the object. As you can see, here it is empty, and if I create this object, it's initialized with name unknown, superpower none. Actually that's that constructor, and then I have another constructor, which is also quite simple. It takes the name and the superpower and initializes the values. So this is something that we already know. I've used also const here as a way that I don't want to change the value here. So this is now where the copy constructor comes into play. What I have here is something different. As you can see here, I had a type string, and here I have a type superhero. This is something that we didn't have in the last week, but this is actually what the copy constructor is about. I say that here I will hand over a superhero object, and then I will do something with the superhero object. Actually, if the copy constructor is called, then I will take the object that is handed into the copy constructor and initialize it with the same values. So when we think about the idea, we want to copy an object, then it makes a lot of sense, because when I copy an object, I want that the name is the same, but also that the superpower is the same. So this is this idea of the copy constructor. So here an example, I'll have already an object hero 1, Superman, and the superpower is flight. And now I want to copy the object. And I just say hero 2, which is my new one, equals hero 1, which means I want that superhero 2 also, or hero 2 also is Superman with this particular ability or superpower. And this is what the copy constructor actually does. So this line calls the copy constructor and not the regular constructor that we have here. So hero 1 calls this constructor since I handed over these two strings, and here I defined that there are two strings. And here I call the copy constructor, which happens or takes place here in that line of code.
So basically it is the functionality of function overloading. We have one function name, which is superhero, in this case the constructor,
right.
And we are using it with different kind of parameters. The first one is without parameters, the second one is with a string and another string, and the third one is just with another superhero. So the same function or the same method with different kind of parameters. This is called function overloading, so using the same function name with different parameters.
And this also works with the constructor here, yeah. Yeah.
Last slide, isn't the string operator also the record in this line of constructor?
Good question. Would be the case if this would happen in the next line. If it's happening in this line where I initialize it, then the copy constructor is called, and if I assign it, then the assignment operator would be called. So this is a really good question. I want to repeat that, and we will talk about that in the, I don't know, lecture in a couple of weeks, where we'll talk about operator overloading. But the question was, why is the copy constructor or constructor called and not the assignment operator actually? Because I assign something here. And this is because it's happening right in the same line of code. So I declare my object here, I initialize my object here, and this is why the copy constructor is called and not the assignment constructor.
Because you're creating operator. A new object.
Right.
And not modifying
right.
an existing object.
Yeah.
Yes.
Would work as well. On the next slide, actually, I have a couple of ways how to do this. So if I initialize an object, I will have the copy constructor. So initializing works in different ways or with different notations. Last week we had the curly bracket notation. We can also put it just in regular brackets or here with the equal symbol. So these are three ways to initialize it and also to call the copy constructor. Here the copy constructor will also be called, and this is quite interesting because we pass the object as an argument in a function, and as we know already from ESP, that was the annoying thing with call by value and call by reference. With call by value, I get a new value. This is a new variable. With the reference, I will get address to the object that I already have, and here I will pass over the value. And so this is why the copy constructor is called, because it's a new object in there.
That's also the reason why we always say, please use references when you call functions, because when you take a reference here, then it's not copied, and it saves much computation time and runtime, because the objects do not have to be copied all the time when you call functions.
And the last point is, if I return an object, then I have the same. This is actually very related to this example. When I put it in a new method or function, I want, or what C++ or the compiler actually does, is to create the new object, but I also want to return it again, like the value. And so also the copy constructor is called again, because I want that what I will do within the function will affect what I return. And this is also the reason why it's called in that case. Okay, so these are ways to call the copy constructor, or actually it's called automatically in that case. And I'll have another example here. I'll have my time class with hours and minutes, and I will have here my copy constructor. And what I do is I just assign values, actually. I also have a function here called syncTime, which synchronizes two clocks, kind of. So it's actually, what's happening here is basically the same what happens here. But I will use this as a way later on to show you about the copy constructor. So I marked here which type of constructor is called. Here in that case, I call it default constructor. I think this is quite obvious because I don't have anything defined here. I have my default constructor here. So if I run this first line of code, the default constructor gets called. Also, here my default constructor is called, and actually this shouldn't be the default constructor. This should be the copy constructor already.
Yes, this should be the copy constructor.
This should be the copy constructor, copy paste error actually. Because this is exactly what the colleague in the last row just mentioned. If I put it into the bracket notation, then I have this situation. So this is also a case where the copy constructor is called. Same as here, and same as here in this function. Here the copy constructor is called because of this particular reason. When an object is passed by its value, then the copy constructor is also called. And since I passed the value of t2 in this method, the copy constructor is called. And this is what our colleague also mentioned earlier. Since I assign here a value, we don't call a constructor because the object is already constructed. We have the object already. But probably we also want that something will happen when I do this. And we will take care of this in one of the next lectures, where we will also show you that there is a way to change the behavior of operators actually. So we could define then that something specific happens when I call the assignment operator. Are there any questions regarding the copy constructor thing? So as you can see, this is something that happens a lot of times because these use cases will happen a lot of times, actually. That was a question.
Yes, so can you please show the next slide?
That one?
So in the fourth one, where is day one dot sync time.
Yeah.
So it will copy the T1 values into T2.
Right. Right. This is what happens there, yeah.
So you, in this line here, the sync time, you mean, right? In this line here, you mean?
Yeah.
So in this case, I don't know if I get it wrong, but when you call this function and you hand over a time, in this case the T2 is copied, so the object is copied into this function as parameter. It is not copied into the T1 object. I don't know if this was your question.
I mean, this happens after when in the sync time. That was not probably the best case to call it also, or to do the same thing as here in the operator. What actually calls the copy construct, or what's the reason why the copy constructor is called, is that I copy it into this function. And so my T1 here in that function, or in that method, actually gets the copy. So this is why the copy constructor gets called. Is it clear?
So no, my question was, will the two have the values of the one, or the one have the values of the
So in this case, T1 will have the values in the end of T2. Yes. So after this line on the right side, T1 will have the values of T2. But I think your naming here
could be better.
Could be better because T1 is getting T2 is getting T1 in the sync time then as the name. Yeah.
So we're calling the sync time function of T1, which are these attribute or this member variables, and I assign the values of T1, which is, and now it gets confusing, T2. If we call it here T2, then it would make it a bit easier with that example. But I agree, the naming style could be better.
Yeah, it wouldn't be too easy then.
Yeah. All right. There's a Slido.
There's a Slido, yeah. So what is a correct copy constructor for a class called animal? These are the options.
All right. I think everyone who wanted to join could join. So let's see. All right. So there is
I didn't
No,
mark it,
no.
but that's the question now for you. What is the correct one? But the audience give you a good hint for that.
It's like the Publikumsjoker. It's
Yeah.
mostly or most of the times it's correct, and in that case it is correct because what defines a copy constructor is the const and also handing over the reference. And you did it perfectly. So this is the copy constructor. Yeah, right. Okay. In the next few minutes, I would like to talk a bit about dynamic memory management. And I know we heard a lot about that in C. Maybe there are some wounds, but we will try to show you that C++ makes things a bit easier.
It's getting better than worse.
It's getting
definitely.
better. Yeah. It's getting better. And also in a few weeks, we will provide you with a super cool feature of C++ that makes life way better. And then you will not struggle that much with dynamic memory management anymore. Okay, so what we know from our experience in ESP last semester is this horrible code. We will have here a malloc, which allocates memory, namely here an integer, and then I will assign a value to the integer.
Somebody fell asleep.
I was shocked from C code in a C++ course.
That's the last time you will see malloc in this course, promise.
Okay. So I think this is nothing new, and I don't want to go into detail, but what is happening here, I'll call free. And then I hand over the address of the pointer, and then it's get deleted from the heap. That's the idea, actually, of what's happening here. Let's have a look how this might be in C++. And here I have other words that are actually doing similar things. Here I have the keyword new, which does actually the same as malloc does. It calls or it like asks the heap for some space to put a time object on it. And what the heap does for us, it returns with an address where this piece of object or memory or whatever is exactly, and then I will store it here in my pointer. So again, I need a pointer because I store an address to this object on the heap. And what's happening here in the next line is I remove this object again by just calling delete t1, and this actually does what free did. I get the address and then I remove it from the heap. Are there any questions to these two lines of code actually? It's as easy as here on the screen.
Yeah.
But
so the main difference is first at delete you don't have the brackets.
Yeah.
Where in contrast to the free. And the cool thing here with the new keyword is that you do not have to calculate how big is an object or a struct or a class. Just write the class name, call the constructor of the class, and it automatically calculates the size of the object and gives you the memory you want to have.
And this is a pretty nice feature, actually, what we have in C++, because in C we always had this size of thing where we had to get the size of from a variable or a struct or whatever, and here we don't have to do that. There is one thing that we should do a bit different, which are arrays. There's a question. Can you please ask the question? If it's less efficient here, nowadays compilers are so highly optimized that we don't have to take care too much about optimizing things. Actually, there are like mechanisms involved in many compilers. So when using a Clang stack or whatever, or GDB stack, then we don't have to care too much about optimization.
That's actually a good question. Because you like C more? Would it be a silly answer?
I mean, there are some. What C++ is good at is memory optimized things that also want to be handled in an object-oriented way. So this is what C++ is especially good at. When you want to dive a bit deeper, then C is a good choice actually because it's much closer to the operating system and the hardware. And in ESP, we didn't cover that depth as you would need it for these kind of things. But in the next semester in system level programming and also in operating systems, then you will see that there are some super cool C features that helps you with especially these kind of things. So yeah, I would say it would make a difference in many aspects, but it depends on what you want to do. So this is like a very generic answer to what programming language over another one is, depends on the use case. But still, C is one of the most popular programming languages. I think there is also this funny joke, which is a bit true. C++ makes it easy for you to shoot yourself in the foot, actually. And it's like that, yeah. It gives you a lot of opportunities and a lot of choices. But at the end of the day, you have to know what you're doing and why you're doing that. And also a lot of overhead. Yeah. That's a good observation, actually. Here it would be. Here we don't care.
No, we
No.
don't care. Of course, there is a mechanism where which happens when there is no more memory available, called exceptions, but we will cover exceptions in a few weeks.
C++ does this a bit different. So what we know from C is we will get some strange pointer back. And as David said, we will get something back, but it's not a strange pointer. It's something that can also crash our program, actually.
And that's the cool thing for assignment 1. You do not have to deal with this case that there is no more memory because we have learned it already. So you are free to use new...
You can spare 3 lines of code. Wow.
Yeah. Yes.
No, I don't think that we have to deal with dangling pointers as well. So the question is, what happens if I access it here? Can try it later on, but overall, no, because I think the compiler will say probably something.
It's already deleted. I also think it says that it's already deleted.
Yeah, probably.
Should not access it at all.
I mean, we can try it now, because I'm also interested in what's happening.
I also have first code open.
Yeah, I'm more familiar with.
Yeah, because you're only writing the exams, all right. You may need a hashtag.
Thank you so much. And so the question...
T1 is equal to, well...
null pointer or something like that.
So null pointer is the equivalent to null.
Oh yeah, I don't have the time
of
class.
Course,
yeah, that makes a lot of sense. Where do I have the time class? I had it somewhere earlier. So let's see if this works already. No matching function.
Okay, you didn't have this constructor here.
Okay. Okay, it works.
But I don't know if online GDB would, would show this warning.
Yeah.
Yes.
After delete, that's the whatever you deleted. So you want to get assigned to null pointer. So after that, is T1 always null pointer?
Is the question if it's null pointer after it's deleted? Might be the case. I'm not 100% sure. We have to check that actually. It would be somehow very meaningful because then I cannot do anything anymore. And in C++, it's not very common to set it to null pointer or whatever afterwards, as we did in C, for example. Okay. Let's talk about arrays. They are a bit different than a regular object. The rule of thumb is actually when I call an array or when I create an array on the heap by using new, I also have to delete it a bit different. And this looks like that. I have also to use the brackets here in that case in the same way as I do it when I call new here. So whenever I want to delete an array, I have to do it like that. So this is the only difference that we don't know from, or which we haven't done in C, where there was some different notation or whatever. Okay, we have another Menti, or Slido, sorry. Please feel free to join.
So what type of constructor is called? So there are two options. The first is for the first line, the second then is for the second line. What do you think? Which type of constructor is called here?
All right.
Let's
wait a bit.
few seconds.
15, 22. Yeah, I think we can go on. Or we cannot go on.
Wrong direction. Yeah. So the first one was a constructor. Maybe we can go back again. The first one is a constructor. The second one then is a copy constructor. Because in the new call, you hand over existing animal in the parameters, and that's why the copy constructor is called. So it doesn't make a difference if you call new or if you make it on the stack. As soon as you hand over an existing animal, in this case, the copy constructor is called.
All right. Cool. Another important thing that we want to tell you about is now how to use the Destructor in a more productive way than we did last week. Last week, we didn't have the opportunity to work with dynamic memory, and this week we introduced the dynamic memory using new and delete. And so this is also the reason why we can work with the Destructor now in a different way. So something that we already did last week, and this is copy-paste slide of what we did last week, is to show you when the constructor is called and when the Destructor is called. The constructor is called here, that's nothing new. And the Destructor is called here because the scope or the lifetime of the object, not of the cat, of the object, ends here. And so it's also saying Destructor is called. Yeah, now we want to do this to clean up what we did with the heap, what we reserved on the heap, whatever. So here I have an example of a playlist, and on this playlist I have some songs, and I want to add new songs to the playlist actually. So this add song method creates a new song and store it in here a vector. And I think we worked already with vectors. So what we know is that with pushback, I just put it onto the vector. And so I have a vector in this playlist function or method or class, whatever, which stores all our songs. This means also that I have a lot of songs on the heap, which I want to delete after that. And this is actually what happens in this line of code. Here is the destructor. And if I call it here, I iterate over the vector and free each and every song. So this is what's the matter with these two lines. I have to do that because I have every song on my heap. And so I have to go through the vector and free every song. Yeah, so the question now could be, when will actually an object be destroyed, or when will the destructor be called? And this depends on the object, what the object actually is. So one thing that we already learned is when the object goes out of scope, then the destructor is called. Also when the memory is freed, so if I have an object which is stored on the heap and I call delete, for example, then I also call my destructor, which is quite nice. And also at the end of the program for everything that is static and global. So this means we still have to keep track of our memory, because when the object or when the program ends, this doesn't count for local variables, for example, and this is the reason why we still use Valgrind in this semester, because C++ is not convenient enough to also take care of this. Other programming languages are dealing with those kind of things, and with a garbage with a garbage collector, for example, that is taking care of bringing out the garbage actually after we run the program. C++ will not do this for us. Yeah, and also another thing is when a thread ends. We didn't talk about threads in this course, so this will be, or this is just for completeness, and this is also something that you will learn in the next semester, actually. Yeah, one thing that we should mention here is also scope, because here I said when the scope of an object ends, then it gets destroyed, and now I want to, briefly tell you a couple of scopes that exist in C++ or in general in many programming languages. So I have the global scope. I think this is nothing pretty new for you guys. The global scope means I declare a variable outside of a class, a method, a function, whatever. I declare it here. And as soon as the program ends, also the scope of this is over. So the scope isn't bound somehow to a specific function or class or whatever. It's bound to the lifetime of the entire program. So when the program ends, then also the global variable will be destroyed. All right. The local scope is also something that should be pretty commonly known. In the local scope, a variable is just accessible within the block, within a particular block. So here in the main, for example, if the main is over, then the scope of this local variable will end. If this is not the main function, because then it ends anyhow. If this is a specific function, I don't know, calculate something, then after this function is called, the scope of this variable would be over. Then I have a block scope, which we have, for example, for loops, for conditionals, whatever. A block scope is defined usually by this brackets. So if I put something within the brackets, it's just available here. If I would use the X outside of here, then it's not available anymore. And I think from our C knowledge, this should also not be something really new. We also have a class scope, and these are variables that are usually accessible within a class and are available as long as the object is still alive. So when the object is destroyed, also the lifetime of this variable obviously will end. And then we will have, last but not least, the namespace scope, which is available within a specific namespace. We talked also about namespaces earlier. As we know, we can access a specific namespace by this scoping operator. And here, for example, this variable namespace var is just available as long as the namespace is accessible. And as we know, this is similar to global variables, so for the entire lifetime of the program, actually. So when the program ends, I cannot access this namespace anymore. Because it's not a function or not a class, here it's a function within the namespace, so it's not bound to like a class namespace. It's here the namespace scope. All right. I think we would now have, our idea was that we will show you now some cool live coding. But when looking at the time, I don't think that we will do this in the last 3 minutes, right? So in that case, are there any questions regarding what we just talked about? Yeah.
For the static members again, you can actually initialize them inside the class by using the inline specifier.
Ich habe es nicht verstanden.
Sorry, once again. With the inline keyword, you mean? Okay, yeah. We didn't talk about the inline keyword. So yes, it would be possible to use static initialization with the inline keyword, yes.
Okay, then thanks for listening and see you in 2 weeks from now. 3 weeks from now. 3 weeks. Good luck with A1 so far.